All right, let's take a look at using the quadratic formula. All right, to start off, in general, a quadratic equation in standard form is ax squared plus bx plus c equals 0 when a cannot be equal to 0. So if a was equal to 0, that means we would be getting rid of this term right here, and we wouldn't have a quadratic anymore. We would have a linear equation. With that aside, we have been solving quadratics by using completing the square. However, from completing the square, we can derive the quadratic formula. This is one to memorize. The quadratic formula. The solutions of a quadratic equation, ax squared plus bx plus c equals 0, are given by x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This would be a formula to memorize if there ever was one. This is a very powerful formula to have. So anytime that we have a quadratic, so remember any quadratic will give us a graph that's in the shape of a parabola. So regardless of where that parabola is, if we use the quadratic formula, it doesn't matter what that quadratic is, we can find those zeros. So remember, some ways that we've found zeros before would be by factoring or other things like that. We can use completing the square to factor things down to solve, but the most or the best way, I guess, or the most well-known way would be using the quadratic formula. So this can be used for any. So because it can be used for any quadratic equation, that's what makes this so powerful. So let's take a look at this. So remember, x equals negative b. Negative b, so you need to look at what is your b term. So in this first example, our b term is 34. Plus or minus. So this gives you two answers right there with that plus or minus. B squared, so we're going to have to do 34 squared minus 4 times a, which is 5, times c, which is negative 7, all over 2 times 5, so all over 10. I'm going to use my calculator for a couple of these computations just underneath the radical there. So 34 squared is 1,156. 4 times 5 times negative 7 would be negative 140. So we get x equals negative 34 plus or minus the square root of 1156 minus negative 140 all over 10. Let's see. So if we're taking the square root of 1296, that's going to give us 36. So x equals negative 34 plus or minus 36. That simplifies down to all over 10. So our two answers, I'm going to bring these back up here so I have room for my next problem. So negative 34 plus 36 gives me 2 over 10. So 2 over 10 is equal to 1/5. And then negative 34 minus 36 would give me negative 70 over 10, or negative 7. So for this quadratic, that's where our parabola would cross the x-axis when x is equal to negative 7 and when x is equal to 1/5. Let's take a look at our second problem. So again, x is equal to negative b, so that would be negative 6, plus or minus the square root of b squared, so I'm going to do that right away, minus 4ac. So that's going to be 4 times 9 times 1. So that'll be 36 all over 2a, so all over 18. So 36 minus 36 is 0, square root of 0 is 0. So we get 6 over 18. If we're adding 0 or subtracting 0, we're going to get the same thing. So this would be equal to negative 1/3. If you only have one answer, that means that this value would be your vertex. Okay? So negative 1/3 is equal to our 1x value for this scenario. All right. We could even double check that too. We could use our vertex formula. So remember, your vertex formula is x equals negative b over 2a. So that would be negative 6 over 9 times 2, which would again give us negative 1/3. So that's just to double check what we just did there, that we're only going to have one answer. Let's take a look. If we have complex zeros, so remember a couple of lessons back, we were talking about complex numbers. A complex number, just a quick review, would be in the form a plus bi. So that first a is a real number, b is an imaginary number. If you combine those two things together, we get complex numbers. So complex numbers with imaginary numbers, that's when we're taking a negative square root. So I'm assuming that we're going to end up doing this in this problem. So let's get after it. X is equal to negative b, or negative 5, plus or minus the square root of b squared, so 25, minus 4ac. That'd be 4 times 3 is 12, times 4 is 48, all over 2a, so all over 6. 25 minus 48 would give us negative 23. So we're going to, x is equal to negative 5 plus or minus the square root of negative 23 all over 6. So if this is going to be a complex number, let me just move up a little bit more, we'll get that out of the way. X equals negative 5 plus or minus the square root of 23i all over 6. So those will be our two answers, negative 5 plus the square root of 23i over 6, and negative 5 minus the square root of 23i over 6. So that would be as a complex number. And then if we have complex zeros. So we have a bunch of fractions to work with. So again, let's jump right into it. X equals negative b, so x equals 1/2, positive 1/2, since b is already negative, plus or minus the square root of b squared, so that would be 1/4. b squared minus 4ac, so that would be 4 times 1 times 1/8, all over 2. So we're going to end up with x equals 1/2, plus or minus. So 4/8 would be, so in that square root we have 1/4 minus 1/2. Okay, so let's get common denominators there. So that's going to be minus 2/4 all over 2. So if I keep on going here, x is equal to 1/2 plus or minus the square root of negative 1/4, or I'll say 1/4 I, all over 2. And then I'll keep going from there, because the square root of 1/4 is going to give me square root of 1 is 1, square root of 4 is 2. So plus or minus 1/2 I all over 2. So if I'm dividing by a fraction, then I should be able to multiply by the reciprocal. so that I can have x equals 1/2 plus or minus 1/2 I, and then I'm multiplying by the reciprocal, which would be multiplying by 1/2. So that would be final answer, x equals 1/4 plus or minus 1/4 I. That's what we would have in the end there. One more. All right, we're looking at travel. Train A leaves the station at 1 p.m. and travels due north at 55 miles per hour. Train B leaves the same station at 4, travels due east at 35 miles per hour. How long will it take for them to get 500 miles apart? So that 500 miles apart is going to be the hypotenuse. So the train going north will just be a simple 55t. Since the next one left 3 hours later and went 35 miles per hour, that's going to be t minus 3. And then our hypotenuse is going to be 500. So we're going to use the Pythagorean theorem to set up this quadratic. This right here I'm going to distribute. So we're going to have 55t, well, let's just go squared, plus, we'll do 35 t minus 3 squared is equal to 500 squared. And I should really put this in a parenthesis as well. I'll have to okay. So 55 times 55 is going to give us 3025 t squared. And then this piece right here, if I'm going to do this really quick, 35t minus 105 squared, this is equal to 250,000. Need to group those together so it doesn't get all messy. So this piece, if I multiply or if I FOIL this out, I'm going to end up with, so 35 times 35 gives me, let's write what we already have, 1,225 t squared. That middle term will be minus 700 or 7,350 t, and then we'll do plus 11,025. It's going to be equal to 250,000. All right. Group those two together. And we might as well group it with the rest so we can keep going. Let's combine some like terms. 3025 plus 1225. So we have 4250 t squared minus, I'm going to save myself one step. Remember, we need it to be equal to 0. So I'm going to do 11,025 minus 250,000. So I'm going to get negative 238,975. Okay, so we have a really We have a lot of nasty numbers going on here. So with this, I can finally actually figure out what my t-values are going to be. So if I am taking a look at this, I can apply these to the quadratic formula. So x equals negative b, so that's going to be 7,350 plus or minus the square root of that squared. Minus 4 times 4,250 times negative 238,975. All over 2a. So 4,250 times 2. Only one of these answers should make sense in the end. So if I take the square root of this astronomical number, $659,750. So let's do divided by 8,500. So I'm just doing the algebra in here. So we'll get two values when we end up solving this little last algebraic piece. We're going to get t is roughly 8.41 and t is roughly negative 6.68. So since we can't have a positive or we can't have a negative time, this is the only one that makes sense for our situation. So after 8.41 hours approximately, that's when those two trains are going to be 500 miles apart. I know that was a lot to take in for that last problem, but if you follow the steps, and definitely would be using a calculator for that one, hopefully it'll pay off for you. So I hope you guys have a great rest of your day, and I really hope that this was beneficial for you.